Hey everyone, and welcome. Today we are going to dive into something really cool, building powerful, super scalable APIs on AWS without ever, and I mean ever, having to touch a server.
Just think about that for a second. Seriously, what if you never had to patch an operating system again? No more waking up at 3 a.m. because a traffic spike crashed everything, and best of all, no more paying for servers just sitting there doing nothing. It sounds like a dream, right? Well, that's the core idea we're going to unpack today.
And that right there is the magic of the serverless promise. You get to focus on what you do best, writing amazing code that delivers value to your users. Meanwhile, the cloud provider, in this case AWS, handles all the messy infrastructure stuff behind the scenes. It can scale from 0 to literally millions of requests without you lifting a finger, and you only pay for the exact milliseconds of compute time you actually use.
So here's our game plan. We're going to start by following a single API request on its journey through a serverless system. Then we'll talk about how to lock it all down and secure it. After that, we'll get real about some common pitfalls and performance trade-offs. And finally, we'll put it all together in a simple architect's blueprint you can use.
Okay, so the best way to really wrap your head around how all these different services work together is to just follow one request. Let's trace it from the moment it leaves a user's device to the moment the response comes all the way back.
Let's make this real. Imagine you've got a mobile app, and a user taps on a product. The app needs to get the details for, say, product ID 123. So it sends a simple GET request to our API endpoint, /products/123.
Now, this whole journey, it breaks down into 4 main steps inside our app. First, the request arrives. Second, the actual work gets done. Third, the data is fetched. And finally, the response is sent back. And what's cool is that each one of these steps maps directly to a specific AWS service. So let's kick things off right at the beginning, the front door, the exact spot where that request first hits our application. That front door is Amazon API Gateway. You can think of it as the receptionist and the security guard for your API, all rolled into one. It catches every single incoming request and is smart enough to know exactly where to send it. It sees that request for /products/123 and knows precisely which service needs to handle it. And that next stop, well, that's where the actual heavy lifting happens.
API Gateway hands the request off to AWS Lambda, which is really the brains of the whole operation. A Lambda is just a small, self-contained piece of code, a function, that's built to do one specific job. In our case, we have a Lambda function whose only purpose in life is to go and get product information. But hold on, a Lambda function is just code, right? It doesn't actually store anything. So where does it get that product info from?
That's where the database comes in. The Lambda function reaches out and connects to a data store to pull the data it needs. This could be a super fast NoSQL database like Amazon DynamoDB, a traditional SQL database like Amazon Aurora, really any database you want. Once the Lambda grabs the data for product 123, it wraps it up in a nice little package and sends the response all the way back to the user's app. And just like that, the journey is complete.
Okay, so we have the basic flow down, which is awesome. But, and this is a big one, what about security? We obviously can't just let anyone on the internet call our API, right? We need to control who gets in. And that control happens right at the beginning, back at our front door, API Gateway.
So you've basically got 2 main paths you can go down here. For most standard cases, you can use a service like AWS Cognito. It's fully managed, and it handles all the user sign up, sign in, and access stuff for you. It's a fantastic way to get started quickly. But if you have more complex needs, maybe you need to integrate with an old system, you can write what's called a custom authorizer. And guess what? It's just another Lambda function that you write to check if a user is allowed in. Total flexibility.
Now, look. Serverless is incredibly powerful, but let's be real, it's not a silver bullet. It's not perfect for every single situation. So let's talk about a few common mistakes people make and some of the key trade-offs you'll have to think about. There are 2 big traps to watch out for. First is what we call a chatty API design. This is where your app has to make a whole bunch of separate, small calls to get the job done, which can really add up and make things feel slow. The second trap is going too far with microservices and creating hundreds of tiny little Lambda functions. This can become a nightmare to manage and can make cold starts a bigger problem. And a cold start? That's just that tiny, but sometimes noticeable, delay you get the very first time a function runs after it's been sitting idle for a while.
And this brings us to the central balancing act of serverless: cost versus speed. They're always in a bit of a tug of war. For instance, you can give your Lambda more memory. It'll cost you a little more, but it will run way faster.
You can even pay to keep your functions warm with something called provision concurrency, which totally gets rid of cold starts. Or you can have API Gateway cache common responses. Each of these things costs a bit more, but they can dramatically improve your performance. It's all about finding the right balance for your specific application.
All right, we've walked through the requests journey, we've covered security, and we've talked about the performance trade-offs. Let's pull all of these pieces together into a simple, solid blueprint that you can use as a starting point for your own projects.
And here it is. This is that foundational pattern we've been building up to. A client makes a request to API Gateway. API Gateway uses an authorizer to check permissions, then passes the request to the right Lambda function. That function talks to a DynamoDB database to get or save data. This simple, elegant flow is the absolute backbone of countless modern, massively scalable applications out there today. And as you start building, just keep a few key tips in your back pocket. Design your API logically around resources, like /products or /users. Stick to the standard HTTP methods. Use GET for fetching data, POST for creating it, and so on. Please, please plan for errors from day one. And finally, log everything. Trust me, your future self will thank you when you're trying to figure out what went wrong at 2 a.m.
This all really circles back to a pretty fundamental shift in how we think about building software, and it's summed up perfectly by Amazon CTO Werner Vogels, who famously said, "The best server is no server." By letting the cloud handle the machines, we as developers are freed up to focus on what actually matters, building great things.
And this really leaves us with one last big question to think about. When you consider its incredible power to scale, its super efficient pay-as-you-go cost model, and how it lets developers be more productive, is this serverless approach the future for all web applications? It's definitely something worth pondering. Thanks so much for joining me on this explainer.